in maybe decades ago, maybe 30, 40 years ago, the main topic and focus in lighting research is visual task. How much illumination actually you need to perform your visual task in different spaces in building. And as we went through global warming issues and climate change issue, the focus has shifted to energy efficiency issue and then decarbonization issue. So those topics has been really important, like a driving force for the past maybe 2 decades. After that, now I can see a new focus, which is on human health and then well-being, and then also environment.
Hi, welcome to Minds Over Matters. There's been an energy renaissance over the past few years. What technologies are actually winning the race for an efficient future? Well, today, our guest is Jae Yong Suk, Director of the California Lighting Technology Center, and he's here to discuss all things energy, from energy-efficient smart homes to how lighting impacts your personal health. Prepare to be enlightened. Jae, how are you?
I'm good. Thank you for inviting me.
Thank you. Thank you for being here. Before we get started today, I want to lay out the premise of what we're going to talk about for the folks at home and just give them a little bit of context, because I think what we're going to talk about is kind of out there. So just a little bit of background. Ladies and gentlemen, Jae is the director from the California Lighting Technology Center, which we call CLTC. CLTC is recognized as a leading resource in the country for the acceleration and commercialization of electric building systems and controls in tech in pursuit of decarbonization, grid resiliency, and community well-being. It is a beacon showcasing through research and design the best ways to integrate efficient and human-centric energy systems into new and existing infrastructure. That's from the website. I didn't make that up. I actually read that, believe it or not. So, Jae, you have been with the center for quite a while, and you've actually ushered it through several changes. Can you talk a little bit about the arc of the development and of the growth of the center?
Oh, sure. You made the introduction really, really good. Thank you very much. CLTC has been known for the leading lighting technology research institution in the nation for the past 22 years. 20 years ago, when LED technology was first developed and introduced into building sector, people actually needed much more detailed guidance, how to evaluate the performance of the lighting technology and the control technology. That's the reason Department of Energy funded CLTC to be established at UC Davis. So we have been leading that effort for the past 20 years. California Energy Commission, actually, which makes building energy consumption code and standard in state of California, it has heavily relied on CLTC's research outcome to refine the code languages for lighting energy consumption in building. Over the past 5 years, especially after I joined the CLTC, we actually expanded our research capacity beyond the lighting technology. The reason is the lighting technology has been very matured, and then also there was a very immediate need to integrate different building systems. As you understand that now we have a much more complex HVAC system, and then also all the smart appliances and EV charging at home. All these systems needs to be more effectively coordinated. So we expanded our research capacity to tackle the new technologies in EV charging, smart home technology, and then smart electrical panel systems in buildings. So that's a new change at CLTC, and then I'm very excited to push that initiative even further.
So a couple things built into what you just said that I really want to touch on. First of all that explains the name, because California Lighting Technology Center, that's a fairly narrow focus, but the center itself studies well beyond just lighting, but lighting was at the core of why you started. So I get that. And thank you for explaining that, because that was one of the big questions I had. Like, it's more than lighting. The other thing is, initially when you were founded, it had a little bit to do with very small federal funding. You that's how you kind of got off the ground. But since then, you attracted major support from major players in technology around the world, that like Panasonic and Toyota. You have. Can you talk a little bit about how you've been able to grow the institute?
Yes, we have very diverse funding sources to support our research activities at CLTC. We, as you mentioned, we started with the federal funding, Department of Energy, along with state funding, California Energy Commission, to start the center 22 years ago. Since then, we have been receiving state funding from CEC, while we also get funding from utilities company in the state of California, PG&E, SCE, SCG&E. Those are very good partners for CLTC. And then at the same time, we also attracted interest from industry partners. For example, if you remember Philips Lighting, their new name is Signify, and then they have been very long partner, very strong partnership with the CLTC for lighting focused research. More recently, we got contacted by automotive industry also. Toyota Boshoku America is a parent company of Toyota. They came us to understand the relationship between lighting and then human stress issue. Panasonic approached us to better understand the user interface and then user response in smart home technology research. So we are attracting a lot of attention from global companies across all different sectors. So as you can see, as I also mentioned that even like a building research itself, there has been a lot of very strong kind of a siloed like a sub-discipline and subsystems, and then there were not really much communication and connection in between. Now we are breaking those silos now, and then we are integrating all the systems into one. At the same time, we are also working with so many different industry partners in very unfamiliar industry sectors. As you can see, architecture and lighting, and then also automotive, industry, and then medical industry, food science. There are so many different industry players. They actually want to work together to come up with new and creative ideas.
So that everything you just said, thank you for that, by the way. But everything you just said points toward, if I'm going to summarize it, is it the quest for greater efficiency? Would you say that that's at the core of what, or is it just coordination of control? Like what's, if you had to summarize, what's the one thing that you think the industry is pointing toward? Everybody seems to want a different share of.
Yes. We are, as we talk, we are making this topic bigger and bigger. But if I just focus on lighting topic, in maybe decades ago, maybe 30, 40 years ago, the main topic and focus in lighting research is visual task. How much illumination actually you need to perform your visual task in different spaces in building. And as we went through global warming issues and climate change issue, the focus has shifted to energy efficiency issue, and then decarbonization issue. So those topics has been really important, like a driving force for the past maybe 2 decades. After that, now I can see a new focus, which is on human health and then well-being, and then also environment. So you can actually see that I think it is the same for any type of disciplines in academia. But I can clearly see that the research, focus is shifting based on the condition, the situation we are facing in the society, and then now the really focus is in the environment and then human That's what I can tell you. Yeah.
Okay, so it's nothing of what you said sounded like it excluded one from the other. There's value, if I'm hearing you correctly. There's value in I don't know, maximizing the human wellness factor. Like what color lighting makes you healthier, makes you more productive, makes you happier, makes you And I know you've done a lot of research to that end that says this is the kind of lighting that will inspire someone or make them more productive. And then there's also, while we're at it, maybe we can control that lighting in a more efficient way. And to the end of, we have to decarbonize, we have to be more efficient. But there are just gains to be made, even if climate change weren't a factor. You would still be in a place where you why not be more efficient? Why not?
Yes.
Why not decrease consumption of electricity in an office building when no one's going to be there, and things like that. And you're kind of like at the grassroots of that, right?
Yes. So just to clarify what I said, we are adding another variable on top of what is already existing. So visual task, again, that has been the main focus, and then no one really thought about the energy efficiency at the time. When we introduced energy efficiency topic, we had to meet both expectations, visual task, and then also energy efficiency. Decarbonization is the same. And then now we are adding another variable there, another aspect, which is human health and well-being and environment. So that actually doesn't mean that, as you said, energy efficiency is no longer important. It's actually still very important. And then we are not compromising energy efficiency and decarbonization goal. Why? Because we are making, building more healthier and then more environmentally friendly. We are still making our great effort to achieve a better energy efficiency while we are meeting all other new challenges.
And it's important to note that you are facilitating this, but it seems like the industry itself is driving this. All your partners that you referenced before, and then whoever else contributes, who comes and asks you for research, it seems that they want a kind of world, that there's a vision of the world out there of where we should move toward, and that is toward efficiency, toward increased human experience and human wellness, and there's an investment in that. And it's as if to say the old ways aren't necessarily good enough. There's a new horizon that we need to be focused on and steer all of our ships toward. So that's what really fascinates me, because I grew up watching like the Jetsons or Star Trek, and you see this beautiful vision of a future that is just like, it's everything, it's all the great conveniences of the world, and
yes.
However they choose to paint it. But it's like an aspirational lifestyle, and it simplifies in theory. We increase the complexity behind the scenes, but your life becomes simpler because you're not doing tasks.
Yes.
You're not controlling your thermostat every 30 seconds. That's being done automatically for you, and things like that. So the house of the future. I mean, and you're not just talking about the house of the future, but that's where my mind goes because of the Jetsons and things like that. Mm-hmm. So tell me a little bit about what you see as being the home of the future. Describe it to me, like 20 years down the lane when all this technology has been vetted, improved, and in place.
Yes. So if I combine all of our, the past, existing, and future research activities, I can actually say that the house of the future, future of the house, you said, right? That is the house which actually is completely automated for maximum energy efficiency. And at the same time, it serves the need of the occupants, make occupants healthier. They monitor occupants' health, their activity, and then serve their needs. So all these different activities and expectations, it actually doesn't require occupants' manual control or direction. It is all automated simultaneously. and then it actually can read the exterior environmental conditions like climate and then weather conditions, and then also energy price from the grid. How we have a dynamic energy price program in California and also in many different states. So read energy price, carbon density, and then the physiological condition of the occupants, and house itself is able to understand all these different variables, make a very good decision, optimized decision for occupant. That is going to be the future of the house.
Wow. So your home becomes a partner in your life. Like it's like a live-in doctor kind of a thing. That's like, your blood pressure looks a little high. Let's change the color of the lights kind of a thing.
Exactly. Yeah.
That's amazing.
Yeah.
And you mentioned energy as kind of a resource, like a grid-fed thing. Do you see an opportunity or a time in our future when energy is delivered on demand? I've heard, and a little wrap around that, like I've heard this phrase bandied about that enough energy visits the planet in the course of an hour that could power us all for a year. Mm-hmm. And it's just a matter of capturing that without disturbing an existing system. Do you see us moving toward making energy independence a thing?
Yeah, that is also the direction in the infrastructure system we have now. But as you also understand, even California, which is known for very high efficiency, like energy control and management, still struggle with meeting demand and supply. Because when there's a hot summer day, everyone wants to use air conditioning at the same time. It actually exceeds the threshold of the grid capacity, and then that actually caused all this power outage issue. Same for the EV charging, right? Everyone wants to charge their EV car at the same time after work. It also caused the serious issue in the grid system. So the key is like how we can balance in between this existing infrastructure's capacity and this constantly changing demand, and then demand of the users, the taxpayers. How we can play with this very dynamic, two very different creatures at the same time, by using the building control system. So that is the main question in our smart home technology research project, and that's going to be the future. I can say that the electrification of the buildings has been very expedited in the past years, and then also there has been also very difficult situations in the utility companies to expand their infrastructure to serve more populations and more buildings, and then we also understand that we cannot just infinitely continue building more infrastructure to serve everyone's need at the same time. So that is a need, like a reason the current technology is really focusing on demand side flexibility, how we can convince individual homeowners and then occupants to make more flexible decisions, flexible appliance operations in their home. So that the demand of this entire population is not happening at the same time. So that is the main focus. And this actually involves a lot of research on not just the technology side, also the human-computer interaction side, how we can deliver that information to users, and then how they can digest those information to make the best decision for their lifestyle, right? So it's very complex issue, but that is also the direction in that in the industry.
So at its very core, at the very least, you are increasing efficiency. So if we were just using regular incandescent bulbs, our use would be increasing over time because the cost to produce the energy that drives that is going to go up internally.
Yes.
So by you increasing efficiency of the things that we use that are electric driven, you're helping us in that way. And also the integration, increasing the functionality of these systems, creating systems where once it was just a one-off or an isolated, a light bulb is an isolated thing. I turn it on, I turn it off. It's not connected to anything other than the power grid. You are building it into a web of control,
yes.
where you're saying, and you're pointing to the house of the future, saying your house is going to be your health advocate as well. It's going to be able to tell you things about that. So increasing functionality, increasing efficiency. Do you see yourself or the center playing a role in informing the people who create energy policy, or are you pretty much just focused on what you're focused on?
Yeah, we are heavily influencing the code development procedure in state of California. As I previously mentioned, California Energy Commission is one of the funding agencies who actually started CLTC 22 years ago. And then they have been also funding our research projects for more than 20 years. All the lighting and the building control research outcomes, they become publicly available. And then those become also evidence for California Energy Commission to further advance their building energy code and standard. So this is like almost like infinite loop of cycle. We get funding from the CEC, and then the money actually is from the taxpayers' money, and then we conduct the technology research. Our outcome goes back to California Energy Commission. That serves the community well-being and then decarbonization, energy efficiency of the taxpayers, community and the society. So I'm very proud that I'm working at CLTC along with 20 different very talented engineers and staff there. And then we are really tasked to further advance the building energy code and standard in the California. And California Building Energy Code and Standard, which is actually called the Title 24, it actually has been also leading the nationwide energy code and standard, which is ASHRAE 90.1. Because we are California, we are leading the nation. So the impact from the research at CLTC is not really stopping at the border of the California. It actually goes beyond. It impacts entire nation. And also we have many visitors from Asian countries and then also Latin America countries. They are coming to CLTC. They actually learn about the partnership and collaboration workflow in between CLTC and California Energy Commission to learn how this academic research institution can better work with the government agency. And then we can make collaborative effort to further, serve the society. So that is the mission. Yeah.
And you bring up a really, really interesting point there because I often hear the technology exists, we just lack the political will or something to actually employ these things. Do you see countries that are getting it right, that have really put their money where their mouths are and said, this is technology, this makes great sense, this will pay a dividend in the future, and have gone full into investing it?
Can you repeat it again?
So other countries, like outside, you hear that we just haven't done this because we lack the political will. We have the technology, if if solar power were an issue, we had solar panels in the White House and when in Jimmy Carter administration. Like that's how old the technology. And if technology alone could solve all of our problems, we'd be okay. We wouldn't have problems. But the thing is, we lack a political will. And that seems to be a very localized thing, like with the United States.
Yeah.
Have you seen any countries that have just embraced, like, bring us your technology, bring us your solutions, we're going to put them in place?
Yes, that's a really good question because I went to, like just this year, I went to South Korea, Japan, and Taiwan to give a lecture and then for the meetings. My role actually is to help our international, like the foreign partners, to learn from us, like how we work with the California Energy Commission. And then that's exactly what they share with me. They don't really have a good working system with their government agencies. So, but at the same time, as you mentioned, these countries actually have also very advanced technologies already developed, tested. They get funding from the governments, and then they already tested those all cool technologies. Very similar level of technology we are doing here. But what I heard is most of those technology is not continued to be integrated into the system because the lack of the relationship with the government agency. So again, my advice to those partners is, to show like how we communicate and then how we being part of this decision-making procedure. Like when California Energy Commission, they tried to revise the Title 24 Building Energy Code and Standard. They revise the code every 3 years. So you can say that as soon as they revised and then released the newly revised code and standard, that's the moment they actually start to prepare the next iteration. So this is a constant procedure, and then they open opportunities for any stakeholder to participate in the process and then speak up, their voices. So anyone who want to share potential opportunity and then challenges and concerns, there is a communication channel. So this is really well-developed system in state of California. So that's why I really have, how can I say, the privilege here to be able to communicate more efficiently with government agency. But it's not actually the same for others in other states, even in the United States, and then also the countries outside U.S.
So in theory, if I'm hearing you correctly, California could become a model for the world because there's an openness, an eagerness to hear what you have to say, to take your recommendations into consideration. And again, if I'm going to I want to just clarify as I see the role. You are talking about examining lives day to day, the need, and how might we make our existence better. You're creating efficiencies around that. You're creating systems that will help support that, will support human health, will support, any kind of support system, whether it be, call an ambulance or bring me food or even any of those things. Mm-hmm. You're increasing the efficiency of those systems regularly. And you are taking that and saying, hey, government, this is what we have established as kind of like the baseline energy that we would need to support this lifestyle. The good news is it's not nearly as grandiose as it would be if all these things were disconnected. That's part of the efficiency that we've brought to this. What can you do about making sure that the power is guaranteed that will support this lifestyle that we are advocating? Mm-hmm. So, and you're saying California is actually responding in that way. They're saying, yeah, let's see what we can do. And that's an entire different entity of the government. Yeah. But at least California seems open to the notion that, yeah, we should probably invest in green energy and fascinating aside.
Yeah.
used to work for an organization that had a nanotech fabrication film, and they produced graphene, and graphene little nanoparticles that also had an incredibly photovoltaic capacity. So in theory, you can infuse graphene into your car paint, and your car will become a giant solar panel. Your clothes could be solar panels. Like, you could gather energy as you walk through the world. And I think there's actually a highway system in Germany that has done that, where the road surface itself gathers energy and then transmits it to, like, charges the cars, the EVs that are passing on it. That's a very aspirational life. That's a Jetsons life, but it's actually in practice. Are you monitoring those things that are happening around the world and say we could make that better?
Yeah. So that's really interesting. One thing I also wanted to mention is the kind of equity issue, because all this, like, a new fancy technology, actually it happened to have a limited impact. The reason is the cost of installation and the maintenance is much greater than the existing system because of all this complexity. So typically, if you look at the architecture industry, I don't know if you have heard the LEED certification, which actually kind of approved that this building is very energy efficient, right? You can also see that those examples are only available in particular sector, particular neighborhood, for those people, like, who can afford to pay the cost of the technology. So when I actually was in San Antonio, Texas, I was architecture faculty there in San Antonio, Texas. And then one of the projects I worked on was the retrofitting the existing roof of the residential building in underserved community. It was actually funded by the city of San Antonio, and then it was not really high tech, but it was a very simple, effective solution to be able to reduce the temperature, overheating issue inside of those residential building. So I just wanted to bring this up because there, as you mentioned, those graphene material which can actually be applied so many different locations and places. I can also assume that the reason it's not really applied everywhere is probably the cost and then the complexity issue. At the same time, even if, like, we develop a more affordable technology, there's still a lot of people who cannot afford those new technologies. So this building energy code and standard development procedure that really needs to consider everyone in the community. And that is the reason, even if we say, okay, this new control system here, it can save building energy for maybe 50%, but it is expensive. This type of application cannot be integrated into the code and standard, because if we do that, there will be so many population in the state who cannot even get the permit of the building, and then who cannot renovate their home because they don't have money to afford those new technology. So, and then the California Energy Commission is really paying attention to that issue. And then they always ask about cost effectiveness of the technology, and then the market adoption potential of the technology. So that is something we are very good at CLTC, because we have a long history of working closely with government agency. But you can also find that sometimes many academic, very focused research don't consider the impact outside the lab or the center, and then make many claims and arguments about the technology itself. But in the end, the adoption of the technology really depends on many other factors, societal factors and economical factors and many other factors. And we really have to consider many of those factors together. Yeah.
Right. So just because we can make a graphene-infused highway for a quarter of a mile in Germany doesn't mean we can actually do that everywhere. That's just that's a really cool thing, like a hyperloop kind of a thing. We can get you from New York to LA in an hour, and we're using a hyperloop, but we just can't afford to actually build it, kind of a thing. But we'll make a model that looks cool.
There was actually the very cool technology also, the transparent photovoltaic like a photovoltaic film. You can sandwich in between the glass panel, so it's this transparent window, but still it generates electricity in building. So you can see through it, but it generates electricity.
That sounds affordable.
Yeah, it's very cool, but the problem is the PV panels usually have a very low efficiency. So it really doesn't generate like 100% or even like 80% of the solar radiation it actually absorbs to generate electricity. I think it's like 30%, even lower than 30% in the real application. That very cool technology actually has even much lower electricity generation efficiency. So people soon realize that, when you have a such a technology which actually doesn't give you the return of the investment, and then those options are not really selected for the future building design and construction. So that is also one consideration you need to make.
Right. Yeah, as part of a system, maybe that's we're recommending an energy mix across this building. That one of the things we could do to help us increase efficiency by this additional 30% is put photovoltaic film between glass windows. But the core of it is going to be this other big engine. I want to talk about EV charging because as I see it, that's kind of like a microcosm of everything you do. You've got everything in there from the technology, and the technology, I mean, like, you hear a lot of people say negative things about what it takes to make a battery. Like there's an environmental price tag to all those kind of things to make and sustain and rehash batteries. And so when you look at that, if increasing the efficiency of charging, making batteries so that at a high energy exchange rate, you're not melting them, you're not rendering them landfill after a certain amount of charges. You're looking at the increased longevity. You're also looking at the infrastructure. What's realistic that we can create, that we can reproduce locally across the country? And then you're also looking at battery technology itself. Talk me through the EV charging schism as you see it, and how do we look at that as a model for where the country might go, or the world?
I'm not really an expert in EV charging technology, but we do study with EV charging technology because the future home, it actually has an EV charger, and then EV charging itself actually becomes one of the biggest energy load in building. So EV charging is really important. The type of research we have done is actually to reuse the EV car batteries for home operation. So if you have a EV used car, when you actually either sell it or dispose it, the battery can be still functional, even though the capacity is not going to be 100%. Still, maybe it has a 60-70% of the capacity left, and then we can actually use those used EV car batteries to operate different home appliances at home. We, in the typical, like a normal days, we don't really need to have an additional battery to operate our home appliances. But if you have power outage issues, and then if that outage issues goes several days, and then having additional energy storage system ready at home, that can be very important. So we had an idea also, and then we had a collaboration with another the professor at UC Davis to find a way to reuse the EV car batteries for home appliances operation for those critical moments at home. Another one is this is the existing projects at CLTC. We actually work with California Transportation Department, and we are working to find out how we can use this heavy load, heavy duty trucks. The trucks like a sweeping trucks. I don't know how to call it. Those sweeping trucks. In California, we have many EV sweeping trucks, and again, when you have a power outage over any like grid system malfunction, how we can use those energy stored in EV sweeping trucks to operate the critical buildings like hospitals and then government buildings, firefighting like stations and police stations. We can find a way to connect the EV cars, multiple cars, to the building, so the building can actually operate its systems as it draws electricity from the EV cars. So that is ongoing research we are doing with transportation department now.
So electric vehicles can actually save lives.
Yes.
That's very cool.
Yeah.
That's really cool. And I wasn't aware that you could repurpose those batteries from EVs that are depleted or on the fringe of being effective.
It is actually called a bi-directional EV charging. So the building can charge EV car, but at the same time the EV car can charge the building itself. So the building can actually use that electricity to operate different types of appliances. There have been multiple startup companies actually who developed this system, and then they also send their prototypes and the new products to CLTC for us to test their performance. Because the really cool thing about being at UC Davis is we are in the public university. We are very independent. I'm not very concerned about like making like a one particular industry unhappy or one company unhappy, because what we do is really based on a science, on research, and we are very transparent about the research activities and outcomes we are doing. So many companies are approaching to us. They also expect us to be very transparent and honest with our testing. So, and we are very good at it. So we are very good at evaluating performance and then sharing the performance with our either industry partners or other agencies. Yeah.
So you kind of say, first of all, I have to say, I've not been to see to the center. I imagine it's amazing. Like it's like Wonka, like Willy Wonka's chocolate factory, but for like electronics and systems and things like that. It must be fun to just walk through and see all the different things that are going on. But you sitting where you sit, you're watching all these different industries that are coming to you for your expertise in all these various components of building this tremendous system. You start to see a pattern emerge of that you kind of shared a little bit about what the future of the homes would look like. If the last thing I want to ask you is, what do we have in place right now that the average person in the country their minds would be blown if they knew this technology existed?
For home, you mean?
For anything. Like what are you working on that you're like, if the world could see this?
I don't know if I really understood your question correctly. Can you just refine that?
So you're in this every day. You're doing work in different things every day, and you're seeing this emerging society, like the vision that these different companies have as a society, and you are currently sitting on technology that you have worked on that's just not really been deployed yet.
Yeah.
And some of it would probably shock the world if they knew this is coming. So I'm not asking you to spoil anything, notify any privacy agreements or anything like that. But can you share something that you're working on now that when it hits the market is going to be a game changer?
Again, we are going back to the CLTC's original mission, lighting. I really see huge potential and impact to the society if we understand this health aspect of lighting, circadian rhythm, stress mitigation, even migration relieving spectrum, and then work performance attention. There's so many different researches are happening. I'm working with many different medical centers across the United States, and then sharing all these new research outcomes. And then I really cannot imagine how we are gonna be benefited by having this new lighting technologies and spectrums applied to the right application, and then help people to be healthier and happier. That's actually what I really cannot wait to see. The technology I'm dealing with is really diverse, and then there is really broad. And I'm glad that I have good background. I studied architecture, starting from design of architecture, lighting also design, and then technology research, and also other building systems research. I had a very broad background, but I'm not an engineer. So if you ask me about technical, detail about any of these engineering topic, I probably cannot answer those questions. But I can understand how those technology work and then can be applied. So my goal is to really, CLTC to not to separate either lighting, non-lighting topic. We embrace everything, based on what we have already established in the past 20 years. And then the lighting can become a very important core of all this future research activity. And then we can, represent the future of the building, and then building controls technology. That is my goal, and then mission at CLTC. Yeah,
that's pretty Star Trek. Yeah. I'll give you that. Like, buildings that listen to you and feed off your rhythms. I think that's fascinating work. Thank you for joining us today. I really enjoyed the conversation, and congratulations on the success of CLTC. Look forward to finding these solutions in my home someday very, very soon. Thank you.
Thank you very much.
Sincerest thanks to today's guest, Jae Yong Suk. If you'd like to learn more about Jae and his work, check out our YouTube page for links to his bio, books, articles, research, and more. And thank you for joining Minds Over Matters today. You can find us on YouTube, Spotify, and Apple Podcasts. Please subscribe, share with your friends, and spread the word. We have a lot to say, and we guarantee something for everyone. Minds Over Matters is hosted by Ed Kiggins, produced by the College of Letters and Science at UC Davis, and filmed at the Y Pavilion. Thanks for listening. We'll see you next time.